Hey everyone, welcome back. Today we're going to look at two variable equations. And so a solution to a two variable equation will be an ordered pair, x comma y. So here's some examples of two variable equations. We have x squared plus 3 equals y, t minus 4u equals 5, root of x plus 2 equals m. So you can see how there's two variables in each of these equations. Today we're going to look at linear equations. So these are some examples here. 2x minus y equals 4, y equals 4x plus 2, 6y equals 9x minus 1. This is all x and y, each of them to the power of 1, like that. And this is pretty much an intro to linear equations. Next year we're going to study linear equations in much more depth. So example 1, find three pairs of solutions to this equation, y equals 4x plus 2. So let's just set x equal to 0. If x is 0, then we plug in x equals 0 here. And so we have 4 times 0 plus 2, right? I'm plugging in 0 into here. So 4 times 0 plus 2 equals 2. And so that's the y value. So the solution is 0, comma 2, like that. So this is a solution to this equation. Next, let's just put x equals 1. We plug it in, and we get 4 times 1 plus 2 equals 6. And so 1 comma 6 is a solution to this equation. Next, let's just go with x equals negative 1 this time. We plug in negative 1 into here. 4 times negative 1, negative 4. Negative 4 plus 2 is minus 2, like that. So one solution is negative 1 comma negative 2, like that. Okay, your turn. Go ahead and find three pairs of solutions to this equation right there. Go ahead and pause the video and do that. Okay, we're back. So if we put x equals 0, y equals 3, so we get 0 comma 3. X equals 1, we get y equals 1, so 1 comma 1. X equal 2, plug it in, and we get negative 1, so 2 negative 1 is the solution. And if you had other points that are also a solution, that's fine. I just found three pairs, so these are three pairs. If yours are different, that's okay. So when it comes to two variable equations, there's a nice relationship here. You can have the equation, or you can have the graph, or you can have a table, and from just the table you can get the equation and the graph, or from the graph you can get equation and the table, or if you're given the equation you can find the table and graph. So these are all three different ways of representing the same information, and each of them have their own advantage. So let's look at a bit more example 1 here. So this was from example 1 here, like that. Y equals 4x plus 2. And so the points that I found were minus 1, minus 2, 0, 2, and 1, 6. And if I put them in a table like this is a nice way of organizing that data. And so from this table, we can go ahead and graph. We can say, okay, minus 1, minus 2, minus 1, minus 2, there's our point there. 0, 2, 0, 2, there's another point right there. 1, 6, 1, 6, like that. And so because we can have points in between these given points, so it's a straight line, it's not a dotted line. And so we have here our graph as such. One thing that's important is to have the axis labeled, both of them, x and y, like that. You put in a few numbers to let us know that you're increasing by 1 or increasing by 2 or whatever. Here you're increasing by increasing by 1 for each axis. And you write the equation beside the graph like that. If you do all that, you made a good graph. So a couple points here. If your solution to the equation, you're a point on the graph. And if you're a point on the graph, you're a solution to the equation. Right here, this equation. And the other thing is that the value that is in the table that is consistent with the rule of the table. So let me explain what I mean by that. Here, from example 1, we have our points, and we notice that if we increase by 1 for our x, we increase by 4 for our y. Increase by 1 for our x, increase by 4 for a y. Increase by 1 for an x, not increase by 4, so it's not consistent with the rules from the other point. And so 2 comma 7 is not a solution to this equation. So that's one way of looking at it. Another way is to simply plug in these points into the equation. So here we have x that we plug in for 2 and y that we plug in for 7. So 7, question mark, does it equal 4 times 2 plus 2? Turns out it doesn't. 7 does not equal 10. So in other words, 2 comma 7 is not a solution to this equation. Okay, example 2. Determine if the ordered pair is a solution to the equation. So this point to this equation, this point to that equation, this point to that equation. There you go, like that. So 3 comma 1. So the 3 is the x as such, and the y is the 1 as such, which gives 3 on the left side and 3 on the right side. So 3 comma 1 is a solution to this equation. B, negative 2 comma 2. So 5x, so we plug in the x here, 5 times negative 2, like that. 3y, plug in 2 here, so 3y. This gives us negative 4, and it's not 2. It's supposed to be 2 if it is a solution, but it's not. Therefore, it is not a solution to this equation. C, 1, negative 1 for this equation here. So negative 1 is the y value. 1 is the x value, like that. So negative 1, does it equal 2 times 1 minus 3? Minus 1 on both sides? Yes, it does. So this point here is a solution to that equation right there. Okay, it's your turn. Practice number 2. Determine if the ordered pair is a solution to the equation. Okay, we're back. So A, 4 comma 3, so our x is 4, y is 3. Plug that in and we get negative 2. It's supposed to be negative 2. Perfect. 4 comma 3 is a solution to this equation. B, negative 5, 6. So we plug in 6 for y, plug in negative 5 for x. We add this up, it gives negative 9, and it's supposed to be 7 if it is a solution. It's not 7. Therefore, this point, ordered pair, is not a solution to this equation. C, 0, 0. So y is 0 and x is 0. If we plug that in, we get 0 equals 1, which is not true. Therefore, 0, 0 is not a solution to this equation. Okay, example 3. Graph the equation with the help of a table. So here's our first equation. Put in some numbers. So you'd like to keep it simple. So just negative 1. If you plug that in, you get 1 for the y value. 0. If you plug in 0, you get 2 as a y value. X equals 1. Y value is 3. X value 2. Y value 4. And so now we're going to plot these 4 points. So you have negative 1, 1, 0, 2, 1, 3, and 2, 4, like that. And so we have our graph as such. X, y axis, y equals x plus 2 is our graph right here. B, 4x plus 2y equals 8. Whenever it's in this form, what's really helpful is plugging in the zeros. So if x is 0 here, this is gone, and you have 2y equals 8. Divide by 2 on both sides, y equals 4. So 0 comma 4 is one of the points on the graph. Next, let's plug in y equals 0. So if y equals 0, this is gone, and what's left is 4x equals 8. So if we divide by 4 to isolate x, we get 2. So here 2 comma 0 is the other point on this graph. And so we can graph just this here. So 0, 4, 1, 2, 3, 4, 2, 0, 1, 2, like that. We plot that, and there is our graph for 4x plus 2y equals 8, like that. Practice 3. Graph the equations with the help of a table. Go ahead and pause the video and do that. Okay. First one, y equals 2x minus 3. If we plug in 0, we get minus 3. If we plug in 1, 2 minus 3 is negative 1, like that. Plug in 2, 4 minus 3 is 1. So here are some points on our graph. So 0, negative 3, 1, 2, 3. 1, negative 1, 1, negative 1. 2, 1, 2, 1, like that. So those points are plotted. Draw the line. So there's our graph of 2x minus 3. B. Y equals negative 3x plus 4. Plug in 0, y equals 4. Plug in 1, negative 3 plus 4 is 1. Plug in 2, negative 6 plus 4, negative 2, like that. So we plot our 3 points like that, draw our graph, and we're done. C. 2x plus 3y equals 6. So let's plug in x equals 0. This is gone. Now we can divide by 3 on both sides. Y equals 2. So 0, 2 is a point on the graph. Let's plug in y equals 0. So y equals 0. This is gone. So we have 2x equals 6. Divide by 2 on both sides. We get x equals 3. So 3, 0 is another point on the graph. So 0, 2, 1, 2. 3, 0, 1, 2, 3, 0. And we draw our graph just like that. And it's that easy. So I'll see you guys in the next video.